Thank you so much again, Eric. Our next speaker today is Matthew Graham. Matthew is an expert on astrostatistics and time domain phenomena. He's been part of several surveys, including Catalina Real-Time Transient Survey and Palomar. And today he'll be telling us about the experience of the Zwicky Transient facility where he's the project scientist. Matthew.
Okay, thank you, Gautam. Can you see my screen?
It's a white screen right now. I'm wondering if you have the right window chosen.
So I think you have to unshare and share again.
Yeah.
That's worked.
Okay. Right, thank you. For people who don't know, my name's Matthew Graham. I'm the ZTF project scientist. So if you want to work with real alerts now, as several of the brokers already, like LSSTC, Antares, Lasea, think, please contact us. So we've just finished our first phase. I don't know what's going on there. Okay. Okay, we've just finished our first phase one, which has been the last 3 years. We had the start of the survey March 17th, 2018. We observed 920 nights, data taken on 734, so we had about 80%. So we used the 48-inch telescope at Mount Palomar. It's smoky this morning in Pasadena. That's why I'm thinking about Mount Wilson. We've taken about 480,000 exposures in that time. The total amount of sky we have surveyed in this 3 years is 22 million square degrees, which is nominally what LSST will do in its 10 years. So we have a 47 square degree field of view. We go down to about 20.5 magnitude with 30-second exposures. Most interestingly for the brokers is that we've put out about 300 million alerts so far. And about 100 million of those have been in the public stream, 200 million from proprietary and Caltech data. 6.5 million of those associated with known solar system objects. We've also done 3 data releases, 5.6 billion sources total in GR and I, and lots of science publications. But what's of particular interest to this group is the, we have a lot of experience about pumping lots of alerts out, typically about 500,000 a night, and also that ancillary in data, which is important. So what have we learned in our 3 years of doing this? Well, particularly in regard to the sort of brokering issues and people thinking about. So there's always been this issue about the fire hose. Do we need to be worried about that? No. I think what we now understand is ZTF is about a 10% LSST in many ways, except funding and resources. But scaling up from the ZTF level of alert distribution, alert management to what Ruben will do is entirely manageable. It's a factor of 10 increase, if anything. The other thing we have learned is that we initially thought we would be putting out about 1 million alerts a night. More realistically, that's come down to 500,000. More realistically, what the end users are interested in is not the full alert stream. Most of that stuff comes from variable stars, and you're actually the number of alerts that your end users typically are looking at, typically working with, is in the few thousands a night. So we adequately have technology to handle this. So a lot of the sort of big data hoopla about what we've been doing and about what Ruben is doing, I think is just that. It's it's propaganda. New thing, reinventing the wheel. Within the project, we've had many groups all trying to do the same thing and all coming up with their own way to solve the same problem. For a small group like us, and I think this is true even for a large operation like Ruben, we have finite resources, and better communication, better operations to stop people just trying to solve the same problems. These are both scientifically motivated, but also technologically motivated. We have about 3 or 4 APIs across the ZTF project, which is, let's say, 100 people, for accessing data through Ursa. And those all sit in different GitHub repos. Really, there only needs to be one for everyone to use and should be agreed on. So there's a sort of wasted effort there. So you need to be really careful about that. AI in the loop. So there's this thing about humans in the loop, say, artificial intelligence is machine learning plus training data plus humans in the loop. And the humans in the loop you use for doing a lot of the training, and Eric sort of hinted at this a bit. The problem with having humans in the loop, even with the data streams you're looking at, if you have several thousand a night and you've got people who are scanning those alerts and whatever, is latency. They can only do it the next morning. There's inefficiency and there's non-repeatability. There's no guarantee that the same person looking at the same alert on successive mornings will give it the same classification or the same recognition. So I think one of the things we're moving towards is fully automated AI complete systems. And I think that's, we're seeing that with some of the brokers as well. But the thing you got to push back against there is that the user base is actually maybe not so happy about that. There's an element of trust there still, that they think that they can do better than an AI. And we can prove demonstrably that the AI systems can do better than the humans, and they don't like that. So there's an issue of confidence that we need to instill in our users going forward as we move more AI systems into mainstream classification. TNS does not want asteroids reported as supernova, but we need to convince them that that will only happen once every 100,000 instead of once every 100 or whatever. History is important. ZTF alerts provide a 30-day rolling history window in the alert packets. This is vastly insufficient for what most people want to do. This is why most of our brokers or end users end up having repositories where they're storing the alerts, and then they construct much longer light curves to work on that. Our internal data systems field millions of queries a day for data in terms of what has this object also been doing. Even within ZTF data, what are the previous alerts associated with this sort of thing? So I think this is something to be really careful about. It means brokering systems really have to have a repository aspect to them, because you're going to be hit for data, or you're going to have very good APIs into the LSST data archives. I think the other really important point is alerts only give you the 5 sigma sky. Particularly in ZTF, we use a 5 sigma detection for doing the alerts. So if your source is 19th magnitude and it goes up by 0.2 of a magnitude, you're not going to get an alert from it. And this affects a whole load of variable signs, both stellar and AGN. You'll only get the things that are being the most active at that particular point. And so what you end up doing is there's a whole load of phenomenology that you're missing through the alert stream. That is, in some ways it could be alert. They could be slow moving transitions, or they could be, slow flares or something like that. And the archives are the only thing currently that allow you to do that. And with 6-month cycles, you're at least 6 months out of date then on what you're trying to do. Rates are really important as well, trying to understand your false positives, or is what I'm seeing rare, or how can I get this? And again, that's where the archive important, both in terms of light curves, but also in terms of alerts. How many times have I seen this type of alert in the past in this region of sky with these conditions? And again, that's where you really need to have a repository of alerts that may be tied to the brokers for doing filter development, that sort of thing, for example. We all seem to be heading towards one-stop shops as well. There's this, the initial breakdown of components in the alert infrastructure world when ZTF started was we would have marshals, and then we have brokers, which are sort of like marshals, but not. And we have repositories elsewhere, and then we have TOMs for communicating for the follow-up facilities. And these are all getting amalgamated. We have a brand new open source thing that we're bringing out for ZTF phase 2, which is called Fritz, which is a combined marshal. This is replacing the 5 marshals we have internally in ZTF for solar system, transients, target of opportunity, galactic variables, and I'm missing one, but have a look at it. It's based with Josh Bloom's Sky Portal stuff and the Kowalski infrastructure that we've developed, and it's supposed to be new and performant. But the whole point is that we've come to the conclusion that really you just want a one-stop shop for all of this, and this may affect how we're thinking about broker development going forward. You may end up not folding more and more thing into something that's maybe quite monolithic. And so we maybe need to be a little careful about sort of building these super apps, which are far more in scope than we maybe initially thought about when we were dealing with brokers. We've got about 1,000 days to go, really, if you think that, you know, LSST operations or the alert distribution may be sort of around the end of 2023, early 2024. ZTF2 is just going. We've got funding for another 3 years. So we'll cover those 1,000 days. We're switching to a 2-night cadence in GNR. We are bringing forced photometry into the alerts. That's one of the things we realized, both from community feedback, that's important, and also because Ruben's doing that. And we're also going to have a forced photometry community service on the ZTF data. We're moving to a 2-month data release cycle. That 6-month cycle has not been often enough. So that means that the public data releases will be every 2 months, so that there's only a 2-month latency on data releases then on public data, which is going to be 50% of the observing time. An important thing is we're upgrading at URSA the storage facilities to a light curve data store instead of flat files. So you'll actually be able to query on actual light curves, which is again important. That's feedback we've had from the community. And finally, I'll say that, you know, I think there are 15, 16 brokers who are thinking about putting in. I think we connect to 4 or 5. If anyone wants to receive the full alert stream from ZTF, ZTF2, please contact us. And I'll end there. Thanks.
Thank you, Matthew. There's a couple of questions already in chat. The first one is from Rick Kessler. Rick asks, in ZTF, which request is more common / useful? Requesting specific transient types, requesting transients with generic features, example, peak magnitude and range.
Right, so we don't classify our transients. The transient classification is a post process in the sense that that requires human intervention using through the marshals. So I would say it's actually the more generic is the generic features that people want. They're querying on the metadata that we provide in the alert packets, or they're querying in metadata that can be associated by doing, you know, I want those which are associated with these sources in, you know, the Fermi catalog or something like that. So I think it's that more generic feature rather than specific transient typing.
Another question that we have from Roy Williams: how can we fetch force photometry for interesting alerts and follow up from that from Monica Sadaisam? What will be the look back time for the force photometry service?
The false photometry for interesting alerts, well, it's going to be in the alert packets going forward, so you can either pick it up from the alerts directly. The look back time for the false photometry service will be to the start of ZTF phase 1. So it'll be all the data that is available publicly will go into your false photometry, unless you're a member of the partnership, in which case you'll also have partnership data going into there. But it'll be whatever data is public will go into the service. So it's going to be a moderated service at URSA.
We have a couple of questions in Slack. Do we have time for them?
We should probably move on to our next talk because we're cutting into Mario's time. But please ask Matthew any questions on Slack.